and that's when it moves. So that is one of the frictions we're going to measure today using these little computers here and the force probe. Measures forces. If I pull on here harder and harder, the number gets bigger and bigger in newtons. So we're going to hook that up to a computer. We're going to have force versus time on our graph. And then I would pull. So when I start pulling, like I said, the shoe's not going to move. And we're going to pull harder and harder and harder until it slips. This point where we slip is how much static friction there is. And then once it slips and it's moving, and I'm going to try and pull it so that it's moving at just kind of like a constant speed. And we'll get some little wobbles in here like this. And this kind of flat part here is going to be the force, the kinetic force. And I'll do a little demonstration with my shoe in just a second. Everyone's shoe weighs different, so a heavier shoe you're going to have to pull harder to get it to move. So once we have our static friction force, we're going to divide it by the weight of the shoe. Everyone's shoe is going to weigh different. And this will give us a number that we call this Greek mu. And this is the coefficient of static friction. And the same thing for the kinetic. There's a coefficient of kinetic friction. And that's the number you can compare with everyone else in the class, right? If I have a really heavy shoe, then my force might go all the way up to here. But someone with a lighter shoe might only go to right there, but that doesn't tell you that my friction is better, it just tells you my shoe is heavier. So we're going to divide by the weight so that we can actually compare the friction between the two shoes. Somebody want to help me? Do a quick run.
Shayla, you want to help him?
Okay.
Go ahead.
So come
Go
on
ahead.
up here. There's the run we did before. So hit play on that for me. And we'll pull, it's getting bigger and bigger. And then it slipped. It's hard to test the shoe because there's not a lot of friction. Your prototypes will be better. I don't know if anyone can kind of see the graph. Looks kind of like what I drew on the board. Yeah.
Yeah.
It's bigger and then it slips. So the point where it slipped is the static friction. That was 1.42 newtons. And the kinetic place where it's kind of flat, all 0.14. Do it again. You want to pull this time? I'll play. We'll start pulling lightly. Pull. That's great. The high part. .67. And for kinetic, 0.36. Now see, these numbers aren't exactly the same because every test isn't going to be the same. So we're going to do 3 tests, and then we're going to take the average at the bottom. And then once you've gotten that average, that's what you're going to plug in here, an average static force or an average kinetic force, and then divide by the weight to get your coefficient of friction.
Do we have standards for the weight? Are we going to add the 9?
Yeah, so I weighed this weight. Oh, that's one thing I forgot to do is put the shoe in. That's why these numbers are so much smaller than
Yeah.
this time. for the weight. So you can put the weight in to kind of simulate that there's actually a person in there. Yeah, that would have been way better. So don't forget to put the weight in the shoe. I weighed that one, and it was 9.70 newtons. And then I weighed these guys, if we're using that, like the little armband looking thing with some weight in it, and that was 7.0 newtons. So you're going to take that, and then you're going to add to it the weight of your shoe. And to weigh your shoe, you're just going to hang it on here. And this will tell you the force of gravity on your shoe. Mine's 5.2 newtons.
So you're going to do the weight of your shoe with your prototype on it,
Yeah.
strapped on. So somebody has to volunteer to take their shoe off, not their foot off. I almost said foot off. Don't take your foot off. That would be bad. And